All right, I think yes, we are recording. All right, so we are going to be talking today about section 1.8, exponents and order of operations. And I would like you to go down past the warm-up to the part of your paper that says exponents. Let's talk about what exponents are. Now I'm going to do this with an example. If I have 2 to the 5th power, what that means is I'm multiplying 2 by itself 5 times. In other words, this is 2 times 2 times 2 times 2 times 2. And if I multiply this, this is going to equal 32. Let me blow that up a little tiny bit bigger. So I could read this as 2 to the 5th power. How about this one? I'm multiplying 2. Sorry, let me turn the autofocus off here. I'm multiplying 2 by itself 4 times. This is going to be 2 times 2 times 2 times 2, which is 16. This is 2 times itself 3 times, 2 times 2 times 2, which is going to be 8. 2 squared, that's 2 times 2, which is 4. 2 to the 1st is just 2 times itself, well, it's just 1 2, right? Here, this is 2 times itself twice. This is 2, but there's just one of them. So our answer is 2. And 2 to the 0, this is actually a 1. In fact, anything to the 0 power equals 1. Now again, let's write down how we read these. If I have something to the 1st power, I would read this as 2 to the 1st power. But I have special names for when I raise it to the 2nd power and when I raise it to the 3rd power. I would read this as 2, when I raise it to the 2nd power, we call that squared. When I raise it to the 3rd power, that has a special name as well. We call that 2 cubed. If I raise something to the 4th power, we don't have a special name there, so we would just say 2 to the 4th power. No special name for the 5th power either. In fact, the only 2 that do have special names are when something is raised to the 2nd power, we call it squared. When something is raised to the 3rd power, we call it cubed. I'd like you to make a note here under 2 to the 0 power, and we're going to talk more about why this is, but for now, let's just make a note. Anything raised to the 0 power equals 1. And this is going to be the case always. When we're looking at exponents, or powers as we call them, we have really 2 parts. This 5 we call the exponent, and 2 we call the base. Now I want to talk to you about a really common error that students make. And I'd like to caution you against making this mistake. A lot of times when students see this, -3 to the 2nd power. -3 to the 2nd power is -3 times -3, and we know that a negative times a negative is positive. But if I don't have the parentheses, suppose I have -3 squared. this is a different problem because now I don't have the parentheses, and instead of squaring everything in the parentheses, now I'm really only squaring the 3, not the negative sign. So here, that exponent is only connected to the 3. So my answer then is negative, I'm squaring only the 3, negative 3 times 3, which is negative 9. This is something that a lot of students have a hard time distinguishing between these two cases. All right, so if we take a look at this bottom part here, it's good to know your squares, it's good to know your cubes, it's good to know your powers of 10. What I would like you to do at this point, if you have not filled these in yet, just pause this video and write down what you think these are. This will give you a good idea of what you already know and what you need to practice. So now is your opportunity to pause. I will assume you have done that. And let's go ahead and go through these together. It is good to know your squares. This is going to make life easier, especially down the road. Please check your answers against mine. 11 squared, this is one that I've seen quite a few people struggle with. 11 squared is actually 121. It is good to know your squares from 1 through 15. These are all fair game on any exam. It is also good to know your cubes. 1 to the third is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And then your powers of 10. You'll notice a pattern here. Powers of 10, 10 to the first is 10. 10 squared is 100. 10 cubed, 1,000. If we look at this, the exponent corresponds to the number of zeros. If I have it to the second power, I have 2 zeros. 10 to the third power, I have 3 zeros. 10 to the fourth, 1, 2, 3, 4 zeros. So in general, if I have 10 to the nth power, this is going to be however many zeros n is. Okay, so we're going to have n zeros for any number that we have for n. All right. Let's go down. Negative 1 to the third. That is negative 1 times negative 1 times negative 1. Well, we talked about this. Anytime I have an odd number of negatives, I have positive 1 times negative 1. Anytime I have an odd number of negatives, my answer is negative. So negative 1 to the third is going to be negative 1. Negative 1 to the fourth. These two become a positive, these two become a positive, and a positive times a positive is positive. What do you think negative 1 to the 82nd power is going to be? If you said positive 1, you nailed it. Go ahead and finish the last 3, please, on your own. And I'm actually going to, let's go to the second example. I'll do a couple problems from there. I have negative parentheses 5 to the third. I want you to ask yourself, what are we raising to the third power here? Are we raising the negative sign to the third power or just the 5? Well, because the 3 is connected to the parentheses, we are only cubing the stuff in the parentheses. This is negative, from the negative sign out front, 5 times 5 times 5, which is going to be negative 125. I look at the second one. What am I cubing? What is that exponent connected to? Well, if I look at this, the exponent is only connected to the thing it's touching. It's just touching the 5 This also is going to be negative 5 times 5 times 5, or negative 125. I look at the third one. Now, my exponent is connected to the parentheses and everything in it. Here, this differs because this is negative 5 times negative 5 times negative 5, which is negative 125. Okay. I'm going to do this next problem, and I'd like you to do the two after it. Negative 2x to the third power. Here I have negative 2x times negative 2x times negative 2x. A negative times a negative times a negative is negative. I know 2 to the third power is going to be 8x cubed. Okay. I'd like you to do the last two, please. So again, you are doing these three and these two. Go ahead and flip your paper over. Order of operations. This is one of the major focuses of this course. You will definitely be expected to be a master of the order of operations by the end of this chapter, at least by the end of the course. Hopefully you'll have it nailed down by Friday or by our exam. The order of operations basically tells us which order we should evaluate our expressions. And I really want to emphasize that order does matter here. For example, if I look at this, 15 minus 2 times 3, I have two operations. I have this minus sign, and I have this multiplication symbol. Those are the two things that I need to do to these numbers. Now, if I subtract first, what I'm doing is I would be looking at this subtraction and saying, okay, well, what is 15 minus 2? Well, 15 minus 2 is 13. And then I would multiply that by 3 to get 39. But if I multiply first, okay, so we're looking at these two operations. If I multiply first, what I have is 15 minus whatever 2 times 3 is, 15 minus 6. And 15 minus 6 is positive 9. Now, these can't both be right. So what we've done mathematically, we have created an order of operations that says this is the order you simplify expressions. Do this first, do this second, do this third, so that we don't have this kind of ambiguity. The order really does matter. And the order that we simplify or evaluate expressions is this. I'm sure you've heard of Please Excuse My Dear Aunt Sally or PEMDAS. The P stands for parentheses. Parentheses can look like, sorry, let me adjust this, there's a hole there. Okay, P can look like normal parentheses, or square brackets, or absolute value bars. But in general, P stands for parentheses. You always want to evaluate your parentheses first. So if you have parentheses, simplify the inside of them as your first step, always. E stands for exponents. That might be 3 squared. After you simplify the inside of parentheses, you're going to deal with your exponents. That might be something like this, negative 3 squared. M and D. M and D stand for multiplication and division. And we are going to multiply or divide from left to right. doing whichever operation shows up first. Same thing with, actually I want to elaborate on that a little bit more. You don't have to write this down, but just watch for a second. MD says to multiply or divide from left to right. So let's say I have, and I'm using a little bit of scratch paper here. Let's suppose I have 30 divided by 2 times 3. Even though we write it as MD, that does not mean that we multiply first necessarily. We're going to go from left to right in the problem, doing whichever operation shows up first. So I have an expression here that's all division and multiplication. I'm going to go from left to right. This shows up first. 30 divided by 2 is 15. Then when I multiply that by 3, I get the 45. If I had a different problem, let's suppose I had 10 times, I don't know, let's say I have 10 times 3 divided by 5. Now multiplication shows up first. As I go from left to right, I'm going to do the 10 times 3 is 30, divided by 5 gives me 6. Okay. Addition and subtraction is the same way. We add or subtract going from left to right. So if your problem is all down to nothing but multiplication and division, addition and subtraction, you would go from left to right, doing whichever operation shows up first. For example, let's say I have 20 minus 5 plus 1. Going from left to right, I'm going to do the 20 minus 5. That gives me 15 plus 1 is 16. But that's if you're down to just one operation, just multiplication, addition and subtraction. Blah, blah, blah. Okay. So let's go back to these two problems. Which one was the correct answer? Should I have subtracted first or multiplied first? Well, according to PEMDAS, I am supposed to multiply and divide before I add and subtract. So the multiplication or division has to happen first before addition and subtraction, which means this is incorrect, and this would be the actual correct answer. Okay, I'm going to do an example. I'm actually going to do the trickier of the two. I'm going to do this one here. 70 minus 10 squared minus 24 divided by 6 times 8. This one's a disaster, right? There's all kinds of stuff going on here. But I know that I need to just follow my order of operations. So I'm going to write down what that is. P-E-M-D-A-S, PEMDAS. I look for parentheses. Well, do I have parentheses? Yes, I do. I have this round set, and then I have the square set. If you have multiple sets of parentheses, you always start on the most inside set. I am going to begin with what's inside the most inside set. Now I have 24 divided by 6 times 8. This is all multiplication division. I go from left to right. I'm simplifying that piece right there. Please do not get lazy here. Students make mistakes when they get lazy. I would like to see you rewrite each line after making the appropriate change. So this is 70 minus 10 squared minus, I still have parentheses, 24 divided by 6 is 4 times 8. Now I look at this. Do I have parentheses? Yes, I do. I have these inside parentheses where I could still simplify stuff. So that's what I'm going to simplify. 4 times 8 is 32. I have 70 minus 10 squared minus 32. Do I have parentheses? Yes, I do. Inside my parentheses, I have 10 squared minus 32. Notice there's two operations. I can either use exponents or I can subtract. Well, what should I do first, exponents or subtraction? The answer is exponents. So I'm identifying each time what piece I'm going to simplify. That really helps, especially when you go back and check your work. 70 minus 10 squared is 100 minus 32. Do I have parentheses? Yes, I do. Now, inside my parentheses, I only have that one operation left. I have subtraction, so I can do that. This is going to be 70 minus 100 minus 32 is 68. Once the inside is simplified completely, you don't really need the parentheses anymore. And then the very last thing, 70 minus 68 is 2. I would like you to try the problem on the left. So I'm going to cross out example. I'm going to write this as, please try this problem before coming to class tomorrow. Let's go down to simplifying algebraic expressions. Simplifying algebraic expressions basically means to distribute. You really have two steps here. First step is to distribute. Second step is to combine like terms. I'm going to do the first example. Yeah, I'll do the first example. Okay. So, distribute, combine like terms, those are our two basic steps. Distribute is when you are multiplying into the parentheses. So I look for where my parentheses are. My parentheses are going to be right here. Well, what am I multiplying by those parentheses? I'm multiplying a -2 into those parentheses. Nothing else changes. The 3x squared comes down. The plus 11 comes down. But then when I multiply -2 times x squared, what I get is -2x squared. -2 times +5 is -10. So that's the distribution piece. I have multiplied the -2 into my parentheses. Now I need to combine like terms. Like terms, we talked about this earlier, like terms are things that have, and we can write this down again. Like terms are same variable to the same power. Like terms are expressions or terms that have the same variables to the same power. So then that brings me back to here. Do I have anything that has the same variable to the same power? Yes, I do. I have 3x squared and -2x squared. 3 minus 2x is going to be +1 x squared, and then I have plus 11 minus 10 is going to give me a +1. You don't have to write this 1 in front. In fact, I don't think Math Excel will accept that. Your final answer, the most simplified version, would be x squared plus 1. I'm actually going to work out the next one so you can see another example, because these can be a little tricky. I don't think the ones in your homework are all going to be quite so bad, but let's do this one together. This one's kind of a bear. So I look. I have this 5 that I am multiplying into the parentheses. I have this 4 that I am multiplying into the parentheses, and that's where I'm going to start. 5 times 2x squared is 10x squared. 5 times -7 is -35. Minus, I'm keeping these brackets, 4 times 2x cubed is 8x cubed. 4 times -3 is -12 plus 3. After you distribute, you don't need the parentheses anymore. Is there anything I can do inside the parentheses to kind of clean this up a little bit? Well, what I see is that I can combine, I have these like terms here. negative 12, and positive 3. So I'm going to combine those. Everything else is going to stay the same. 10x squared minus 35 minus 8x cubed. This is going to be minus 9. I still have parentheses with something outside of it. I have a minus sign here. I need to distribute that negative to both terms. And I can think of this as a negative 1 if I wanted to. These two stay the same. 10x squared minus 35 negative, I can think of this as negative 1 times 8x cubed. That's going to be negative 8x cubed. Negative 1 times negative 9 is positive 9. Parentheses are gone. I've distributed 3 times here. Now what I want to do is look and say, well, are there any like terms that I can combine? The highest power I have is this. Does this guy have any like terms? No, right? Because this is x to the third power, this is x to the second power. These guys are not like terms. And we could even make a note here. Okay. These two are not like terms. I cannot combine them because the exponents are different. So it's going to be negative 8x cubed. I can't combine it with the positive 10x squared, but I can put the negative 35 and the positive 9 together. These guys are like terms. And when I combine those, I get negative 26. Woo! All right. So, just to recap, what you need to do tonight, please, before coming to class, on the front page, I'd like you to do these 3. I'd like you to do these 2. On the back page, I would like you to do this you try, and I would like you to do the practice problems on the bottom, these 6 down below. Notice for the practice problems on the bottom, I've given you the answers. I've given you the answers because I want you to be able to check your work. Awesome. That concludes our video lesson for today. Thank you so much.